Hi everyone. So today I'm gonna run through the TwoSum problem in Neetcode. Nothing too crazy here. I just decided to start lead coding again to freshen up, and I figured it might be fun to record my progress and start from the beginning and see how things goes. So yeah, to those of you who are unfamiliar with TwoSum, it's I believe the first problem in Neetcode, which is creation of important Neetcode questions, and it's actually one of the first questions posted on Neetcode. So the idea of the question has a lot of solid fundamentals that you definitely want to grasp before we move on. And effectively, the problem is that we have a list of numbers, or an array of numbers. And I want to find the indices such that those two indices add up to the target value, right? So what do I mean by that? Let's take a look at this example number 1. We have, an array of numbers with 2, 7, 11, 15, and my target number is 9. So the output here is an array of 0 and 1, and that's because index 0 plus index 1, 2 plus 7 adds up to 9. And then you can look at this example down here, 3, 2, 4, target number 6. The output is index 1 and index 2. Because 2 plus 4 equals 6. Now, the first thing you would want to do when you see a problem like this is you want to look at the constraints, right? So, nothing too crazy to worry about here, except that last bullet point, only one valid answer exists. So it can kind of help you out with, error checking and things like that. We know that there is going to be at least one valid solution to this problem. So there are 3 ways to go about this problem. Solution number 1 is brute force. Solution number 2 is TwoPointer. Solution number 3 is HashMap. We'll implement the third one for brevity, but for completion's sake, we'll talk about all 3. And if you're not sure how to do any of these solutions, or the code doesn't immediately come to you, I would encourage you to go back and try out this problem, because you can only learn, right? So say we have an array. I'm gonna make an array of random numbers. Let's say 7, 9, 2, 6. Okay, 7, 9, 2, 6. Easy enough. I'm gonna say that my target number is 8. Okay, so looking at this, really simple, right? Index 2 and index 3. But the question is, all right, how can we, write an algorithm to find this for us, make it generalizable, and make it fast? Well, maybe not make it fast for the first one. The first one is, a brute force algorithm, right? And I'm sure you're kind of familiar with this. The idea is that we would compare every value in an array to every other value in the array. And this is just, a standard for double for loop, right? So for I in our array, and, array, for j in array. So to kind of walk you through this, at the beginning, I is 7, j is 7, I plus j equals 14. Nope, that's not our target. Next, I is 7, j is 9. Nope, so on and so forth. The issue with this problem is that it's extremely slow, right? And that if we were to analyze its runtime, you would see we have an O of n squared runtime. Why? Because the outer for loop will run n times, and it'll do n amount of work each time, right? Because the inner for loop is going to happen every time. N times n equals O of n squared. No bien, we can do better. And again, if the code doesn't immediately come to you, go back and code it. It's important. The second method, TwoPointer. Generally speaking, a prerequisite to TwoPointer is that you have, a list of sorted numbers. So I don't really think that this question is the best candidate for TwoPointer, but people love to do it. So before we were to do anything with TwoPointer, we'd have to sort the list, right? So you would have 2, 6, 7, and 9. Here's our now sorted array. And the idea with TwoPointer is that I'd put a pointer at the beginning, I'd put the pointer at the end, and I would start adding them up, right? So I'd say 2 plus 9, that's 11. Está no bien. It's bigger than my target number 8, so this is sorted. The only way I can make it smaller is if I move this one down 1. 2 plus 7, that's bigger, not smaller. So let's move this number down 1, because that's the only way we can make it smaller. 2 plus 6, 8, bingo. Target number. But then, there are more intricacies here, like you need to store the original indices, so on and so forth. Things like that. Fun, way to solve the problem for practice, but not the best way. What's the runtime? So this two-pointer shenanigans, that's O of n, right? Because we're only going to touch each number in the array once, and there are n values in the array. But what about sorting the list? Sorting in Java, Python, and I believe most other common libraries are going to use quicksort, right? So if you don't know this, now you know. Quicksort has an O n log n plus the n for the two-pointer, which is equal to, O of n log n. We only keep the most significant one. Not the best way to go about things. I think we can do better. In fact, we can. The next solution is a bit trickier, but it's definitely really clean. All right, and the idea is that we use a hash map to store effectively the complement at each index, right? So what do I mean by that? Say I'm at index 7, right? And, hash maps have a key and a value. I would say at index 7, okay, 8 minus 7 is 1. So for me to match this index 0, with another number and have it add to the target, I would need a 1. So I say, okay, make the key a 1. So now the key is a 1. And let's map it to this index being 0. And now I know that if I ever see a 1 anywhere else in this array, I have my answer. So now we're going to move to the next index 1. All right, index 1 is a value of 9. So let me look in the map. Let me see, is a 9 needed anywhere? No, it's not. So let me just do a, 9 minus 8, that's -1 outside the bounds of this problem. But either way, we can just go ahead and add it, -1. Its complement is at index 1. All right, now let me go to the next index 2. I'm going to say, all right, 8 minus 2, that's 6. So I need to find a 6 somewhere in this array. And then this is going to map to index 2. And then finally I see a 6. So I say, okay, 6. Is a 6 needed anywhere? I look it up in the map. I see, oh, look at that. I have an entry for a 6. Okay, I look up 6. I find index number 2. I know my solution is index 3, index 2. Maybe not the best explanation. I'm still working on this, but hopefully the code will make it clearer. So let's go ahead and code this up and see what we got. So let's go ahead. Let's get inside this function. Sorry, I'm on my iPad. And let's take a look. So first, what I want to do is I want to make that map, right? So I'm going to have a... Why is this thing not working? There we go. I'm going to have a map, and I'm gonna want to map an integer to an int. Integer, right? So integer 1 is the complement. Integer 2 is the index. Let me call it, we call it me map or something silly for right now. I'm going to say this is equal to a new hash map. And then, let's see, I'm going to loop through nums. So I'm going to say, we can use an enhanced for loop, but I want to keep track of the index, right? So let's just use a regular old for loop. And I'm going to say that, for int I equals 0, as long as I is less than nums.length, I plus plus, hopefully, right, just a standard for loop. And let's see, what am I going to do in this for loop, right? I'm going to say, if my map already contains, nums I. So let's go back here. Let's go back to our drawing. So nums I. So I'm going to say, okay, as I'm looping through this, is 7 needed anywhere? Is 9 needed anywhere? Is 2 needed anywhere? So it's going to be the first check that we're going to do. If it is, then wow, great, we have our answer, right? That's it. I'm set. So I can say, int array to return is equal to new int of 2, and to return 0 is equal to the value in the map. Map.get, nums I. you know, and then we could say something silly like, you know, to return 1. Oops, sorry, to return 1 is equal to I, because it's the current index, right? And then we can say return to return. Straightforward enough. Otherwise, if that doesn't happen, then we know that we have to insert a value into the map, right? So what value we're inserting? We're inserting the complement. So what does that look like? We're going to say, you know, memap dot put, and the first argument is going to be the complement. So it's going to be target minus numsI, comma the index that I'm currently at, I. All right, and since there's no error checking anything, and we're guaranteed to have at least one unique solution, I think this should work. So let's talk through this again before we run it. I make a map of integers to integers. I loop over the array. First I check, okay, is this complement? There's, you know, this value needed anywhere. If it is, bingo, to return 0. You know, get the old index, get the current index, return it. Otherwise, put target minus numsI, put the complement, and the current index. So let's see here. Let's see, can I go ahead and run this? It won't let me, there we go. Submitting, compiler, bingo, never works on the first try. Always look over your code. Let's see here now. Oh, I don't have premium. Let's wait a bit longer, submit. Another error. In Java, it is contains key. Whoops. Let's see here. I think it is. Hope it is. Okay. Oh, and the compiler is not smart enough to know that this case will always be hit. So otherwise, if that's the case, again, this case should never be reached. Where's Control Z on this guy? It's Command Z. So I'm just gonna return null. And again, we should never ever see this case happen. If we did, I did something seriously wrong. Let's run it again. And bingo, there we go. So not too exciting. Hopefully that was kind of clear. If anyone has any suggestions on how I can do this better, please let me know. But yeah, I hope that was helpful.